Mober Systems.
Welcome. Today we're thrilled to unveil an ongoing project that aims at pushing the boundaries of Web3 data analytics, a holistic approach to support exploring the intricacies of distributed ledger technologies. Join us as we dive into the possibilities and the power of knowledge engineering in Web3. Let's dive in. Mober Systems is a tech startup based in Sao Paulo, Brazil, born out of the shared passion for technology, AI, gaming, and innovation of its co-founders, Dr. Marcio Moreno and Dr. Rafael Brandão. They incorporated Mober Systems in November 2022. Since then, the team has been prolifically contributing to different ecosystems and communities. Mober's current focus is on GameFi and on developing tooling for holistic analyses of Web3 ecosystems. We envision an inspiring world where creativity, diversity, and joy thrive through decentralized solutions. Both co-founders have PhDs in computer science and previously worked as research scientists at IBM for 7 years, where they developed AI technologies, co-authored multiple papers and patents together. Their background includes Web3, AI, knowledge engineering, distributed and decentralized systems, multimedia and hypermedia systems, human-centered computing, among other research topics. Check out our website and GitHub page for more details. Today, we present an ongoing project called the Internet Computer Analytics Platform, or ICAP for short. ICAP is a platform for users to query and analyze data from various sources in the ICP ecosystem. It comprehends canisters and a domain ontology called ICOnto that is designed to represent and structure the main conceptual entities of the ecosystem. As planned in our roadmap, the ICAP platform will comprise NLP mechanisms to parse input queries and extract key entities, relationships, and action commands. This involves understanding the user's intent and mapping it to the corresponding concepts in the ICOnto ontology. This mapping will establish a semantic understanding of the query and allow for effective retrieval. Information extraction pipelines will handle injection of semantic data into the knowledge base, or KB, which will also consider the ontology definition. These components will be in charge of keeping the KB in sync with different data sources in the ecosystem at a configurable rate. The query results will be structured as informative artifacts, visual widgets enriched with charts to enhance the user experience. The summarized results will be presented through a dashboard UI, where users can analyze the retrieved data, refine their queries, and further explore the insights provided. We have just completed phase 1 of the ICAP project and delivered core assets. Our target users range from blockchain developers and data analysts to crypto enthusiasts and IC holders. For instance, developers who want to access specific technical insights and performance metrics for application development and deployment using detailed Sparkle queries. Data analysts which may utilize metrics and trends available in ICAP to generate insightful reports and support better business decisions. Or for instance, IC holders and general ecosystem users who may want to track key indicators relevant to transactions and token movement, or even the network health or maybe governance decisions. The problem we're solving? Simplifying data analytics in the Web3 domain. Currently, analyzing distributed ledger data presents several pain points for users. For one, Web3 platforms often adopt a specific ontology in their conceptual design. That is, they use specific terms and glossaries requiring users to go through tedious documentation to eventually overcome a steep learning curve before exploring platforms. Furthermore, without a standardized ontology and data models across the platform, developers may struggle to integrate data from multiple sources. The lack of user-centered analytical tools tailored for decentralized data analysis adds to the problem, requiring general users to have technical expertise in blockchain technology and data analysis methods. With the current available solutions, including block explorers and GraphQL-based querying tools, users struggle to perform basic data retrieval, as well as correlating data and indicators, let alone correlating data from different networks to extract meaningful insights. In our vision, the potential opportunity is vast. With the steady growth of the Internet Computer Network, the demand for effective data analytics solutions is real. Developing holistic analysis tooling in the ecosystems would provide a strategic edge among other networks, leveraging valuable and unparalleled data insights. ICP offers a comprehensive set of features that appeal to developers seeking to harness the potential of distributed ledger technology. Its core features include canisters for secure and decentralized execution, chain key technology for fault tolerance and decentralization, and the Internet Computer Protocol, ICP, for global scalability across a network of independent data centers. Another differentiator is the possibility of choosing among various high-level programming languages, using Candid for standardized interface descriptions, and native support for internet identity and inter-canister communication. This supports developers to easily create interoperable applications with decentralized identity and seamless interaction between components. The IC SDK and extensive documentation provides a streamlined building experience, which made it a really attractive option for us at Mober. We have just delivered Phase 1 of the ICAP project and delivered an extended version of the ICOnto ontology, a back-end canister that provides a triple store implementation and a front-end canister to allow accessing the knowledge stored in the triple store using Sparkle. The ICOnto ontology features a T-box definition with a total of 461 triples, 74 classes, and 46 properties. By incorporating the main entities and relationships that represents the ICP domain, the ontology ensures consistent definition of key terms, facilitating clear communication and collaboration among developers, researchers, and stakeholders in the IC community. The ICOnto ontology is based on official documentation, glossary definitions, and different assets such as the ICP dashboard. The ontology is expressed in turtle format and defines relationships and properties between entities, providing a foundational understanding of the ecosystem. We've created and deployed a triple store that incorporates the ICOnto ontology and provides endpoints for structured data retrieval and storage. The backend canister uses the ASL CDK. The triple store is a key component that serves as a repository for the ICOnto class definitions, or T-box statements. That is, the very core definition of the ontology, which will be kept in the ICP blockchain. To enable the initial tests of ICAP, we created a preliminary ETL, extract, transform, and load mechanism, to extract transaction records from the ICP network, convert these records to entities according to the ICOnto mapping, and load the converted entities into the triple store. The extraction mechanism uses the ICP Rosetta API to fetch data. We created test units to cover core functions in the ICAP platform. Unit tests for the initialization of the triple store as well as for querying it. Also, unit tests focused on the preliminary ETL mechanism, which asserts extraction, conversion, and loading of transactions in the network, and then verifies if the such transactions were loaded correctly in the triple store by querying for all transactions available in the triple store. A front-end canister was deployed to perform Sparkle queries and retrieve information from the triple store backend. It enables accessing the knowledge stored in the triple store through a simple interface with syntax highlighting. It is currently a tool for facilitating the interaction with the triple store and will be further extended in the future. The next phase of the project entails the cohesive integration of data processing, querying, and visualization components of the ICAP platform. The initial focus will be on data extraction from the internet computer and the creation of semantic ETL workflows to structure data in alignment with the ICOnto ontology. Next, a controlled natural language (CNL) specification is planned to enable swift interaction through natural language queries. A robust query engine component will execute CNL-based queries, retrieving pertinent data from the knowledge base. Finally, the creation of a visualization interface, empowering users to create personalized dashboards by combining diverse informative artifacts. The goal is to facilitate intuitive data exploration and analysis, while enhancing overall platform accessibility and user experience. The proposed modular architecture and API specifications provide features to enable querying, knowledge structuring, and dashboard management. The architecture comprises a client layer with an API for external applications and a front-end interface. The engine layer includes components such as a controlled natural language for query parsing, a query component for structured data retrieval, and engines for generating informative artifacts and managing dashboards. The data layer handles information extraction workflows and knowledge management, ensuring structured representation aligned with the ICOnto ontology. Finally, the ecosystem layer interacts with the IC network, incorporating features for accessing and managing ecosystem data within the platform. We truly believe that the ICAP project embodies a pioneering endeavor capable of redefining the landscape of data analytics within the Web3. We are looking forward to engage with the community, empowering users to delve deeper into the IC ecosystem